Yes, or not done. I have a T-way. Can see to myself that I'm not necessarily should know that I'm not as young as I used to be, where I could get them back by the next day. So at least you're going to get them back on Monday. This is where a lot of people, the math when you're kids starts to go the other way. Adding the fingers. Subtraction, came away. Multiplying, okay, 4 times 3. So I have 4 3s. I can still add those together. But then division is nice as long as it goes in evenly. When it doesn't go in evenly, then we start to get a little anxiety going on. And forget the whole decimal thing. Here come fractions. Division. And at least my experience. And it was really nice when we had the opportunity to teach the arithmetic class. It's sloppiness. You got a 5th grader, 4th grader, sloppiness. Place value. If you put a 1 under a 10's place, you're going to get the wrong answer. You can't subtract 1s from 10s. I'm going to object the computer. I think so. Just now that I've got a little clue, yeah. Hey. They only do America's Funniest Home Videos. Because you can just look, everybody's looking at me. So you don't need that guy on Sunday nights for the show. That guy died. The guy who used to host it, that was on Full House. Never mind. He's died. Bob Saget, that's his name. It's placed on him. And I would see that, long division starts to go like this or like this, and it's lots of things going on. You're dividing, yes, but how do we divide? We got to multiply, then we subtract. It's an algorithm. An algorithm is just a recipe, one step at a time, until you can't go any further. Unless you're doing decimals, and then you keep on going until you round to whatever you're supposed to round to. But here's the news. The steps don't change. Here's where we're headed. And I put this up on the board earlier this week, before we left. We're going to take this polynomial and we want to divide it by x minus 5. So we're not going to be dividing numbers, we're going to be dividing algebraic expressions. And how we do that problem is exactly the same way we're going to do this problem. Exactly the same way. In fact, I'm also going to show you an easier way to do the other problem. That one right there. Okay. All today. The first thing we do, you have the dividend. The dividend and the divisor for a quotient. The dividend is divided by the divisor and the answer is equal to a quotient plus a remainder over the original divisor. For instance, 8 divided by 3. 3 can go into 8 2 times evenly. 2 times 3 is 6. The remainder is 2 with a denominator 3. Basically changing it to a mixed number, 8 and 2, or 2 and 2/3. That's what 8 over 3 is. Improper fraction to a mixed number. What we just did though was this. You take the dividend, and that goes under the good old, I don't even remember what this darn thing is called, the division symbol. The one that we're rarely ever going to see ever again. But for today we will. And the divisor goes out here. And we look at how many times can we multiply 3? How many times can we go into 8? It goes into 8 2 times evenly. 2 times 3 is 6. And then the next move with long division is what? We subtract. And 8 minus 6 is a 2. And we go, all right, let's go again. 3 goes in, 3 can't go into 2. So that's the remainder. 2 remainder 2. We don't write it like this. We write it as 2 plus the remainder of 2 over the original divisor. But because these are numbers, we don't write 2 plus 2/3. It's just 2 and 2/3. We write it as a mixed number. That's how we get our mixed numbers. The biggest problem with the mixed numbers, when I see a number next to a fraction, I'm thinking, hey, that's supposed to be multiplication. So that's why parentheses come into play. If it's multiplication, it would be 2 parentheses and 2/3. So here we go. The way we convert this is into our long division. You're going to take that division symbol. Out here is the divisor. Under here is the dividend. Ever heard the word dividend before? Stocks. Dividend is what is made in the stock market. And what happens to the money that's made? It's divided among the shareholders. It's divvied up among the shareholders. The dividend. That's what we divide. And this almost sounds like an action verb. That's what's going to divide it. It's almost like the villain. It's going to cut up all the money. It's the divisor. So that's what you're dividing by. And the answer up here is going to be the quotient. That's the answer to a division problem. And then you have a, plus a remainder, if there is one, over the original divisor. We take the 49 divided by 5, so 429. Divided by 5, and the first thing we do is we convert it into 5 is the divisor, and we want to know how many times? Into 429. Don't try to get too far ahead of yourself. Don't try to get too far ahead of me. Because what I'm going to do is for hopefully those that struggled with division before, I want to help you the most. Those of you that get it, remember, I always check the work. And I need to be able to read your work. First thing you do is you look at the hundreds place. And you ask, can 5 go into 4? And the answer is no. So there's nothing in the hundreds place. So then you go to the tens place and you look at this as a 42 in the tens place. And you go, how many times can 5 go to a 42? 8 times. So 8 is going to go right above the 2 place value in the tens place. So when we multiply, 8 times 5 is 40. It terminates, the 40 should terminate right under the 42 in the tens place, because this is in the tens. So this is actually an 80 times 5. That's why I put it in the tens place, which means this is actually 400. Because I'm operating from left to right. 5 can't go into 4 in the hundreds, so I'm now in the 10th place. If I'm in the tens, this is technically 80. That's where the 8 is. So 80 times 5 is 400, because it's lining up under the 4, which is in the hundreds place. You don't have to put the 0. I always do, because I want to make sure everything lines up. If it doesn't line up, then you're going to have problems. What's the next step in long division? We subtract. 9 minus 0, 9. 2 minus 0, 2. 4 minus 4, 0. So we have 29. Now you go 5 into 2. Tens place, we can't go any further. 5 can't go into 2. So now we go to the ones place. From the ones place, we're looking at 29. How many times can 5 go into 29? 5 times. So in the ones place, you have a 5. 5 times 5 is 25. So now in the ones place, we have a 5 times 5, 25. And then we subtract again. 9 minus 5 is 4. 2 minus 2, 0. You have a 4 in the ones place. Can 5 go into 4? No. That's my remainder. So I have this answer as an 85 was the quotient, and then technically plus the remainder of 4 over 5. But because these are numbers, we wouldn't write plus 4/5. We would just write 85 and 4/5, the next number. This is not about what your calculator does, because your calculator is not going to give you all the work necessary to do that, and that's where we are going. So now, instead of dividing by 5, we're going to divide by 11. So the divisor is 11, so that's what goes on the outside. The dividend is 429, so that's going underneath again. And you go by place value. The first number is a 4 in the hundreds. 11 doesn't go into 4. So we're done in the hundreds place. So now we go to 42, which is in the tens place. How many times can 11 go into a 42? 3 times. 3 times 11 is 33. 3 times 11, I get 33. Which is a 330. Since this is in the tens place, it terminates right under the 10. And so from the perspective, this is 300, that's a 30. 330. And then we subtract. 9 minus 0, got a 9. 2 minus 3. Well, we can't take 3 from 2, so we got to borrow. So that's a 3, and that's now a 12. 12 minus 3. We get a 9. So we look at the tens place. In the tens place, we just have a 9. 11 can't go into 9, so we're done in the tens place, obviously. So now we're in the ones place, and in the ones place, we're looking at 99. How many times can 11 go into 99? 9 times. So 9 times 11, 99, subtract, and we get 0. And you don't need to go plus 0 over 11 because 0 over 11 is what? 0. And 39 plus 0 is 39. And that's my whole point about simplify completely. You would just put 39. You wouldn't have to do all that. It went in evenly. You don't have a remainder. Divisor of 106. Divided into 429. So 106 is not going to go into 4. So there's nothing in the hundreds place. 106 is not going to go into 42, so there's nothing in the tens place. So you're going to start right above the ones because the only thing 106 could possibly fit into is the 429 to begin with. But you know what I'm going to see is I'm going to see, all right, it's going to go in, it looks like it's going to go in 4 times. And they'll just put the 4 randomly somewhere. If you don't practice the right way every single time, you're going to mess it up eventually in the future. Practicing it the right way is going to help you more than you know. Place value means everything. So in ones place, 4 times 106 is 424. Then what you practice? 9 minus 4, you get a 5, and 2 minus 2, 0, 4 minus 4, 0. That's it. It's 4 remainder 5. So that means it's 4 plus 5 over 106, or 4 and 5, 106. So, first thing, the divisor is the 25. And the dividend is 45,086. And I hope you see that it does make a little bit of a difference. The neater you write it underneath, maybe spread it out and not bunch it up so much so you have some room to work. This time you look at it from the 10,000th place. 25 can go into 4. So you're done with the 10,000. Now you go to the 1,000. And you're looking at 45. How many times can 25 go into 45? Just once. So in the 10,000s place, sorry, in the 1,000 place, you have a 1. So this is 25,000. Okay. 6 minus 0, 8 minus 0, 0 minus 0, 5 minus 5, 4 minus 2. So we're at 20,086. So we're done in the thousands place, so now we go over to the hundreds place, right above this 0. So from the hundreds place, we're looking at these 3 numbers, 200. How many times can 25 go into 200 even? 8 times. 8 times 25 is 200. So from the hundreds perspective, this is going to be an 8 in the hundreds place. 8 times 25 is exactly a 200. Since that's in the hundreds place, it's 800 times 25. So 800 times 25 is going to be 20,000. If you had 800 times 25, well, let's see. You really are just going to go 8 times 25, which is 200. And then you got 2 extra zeros, so you add 2 extra zeros, 20,000. You know why? This is exactly the same as 100 times 8 times 25. 8 times 25 is 200. And 100 times 200 is 20,000. So what's the key? Anytime you multiply by a power of 10, just multiply the leading number times whatever that is. If you have 3 zeros, add 3 zeros. If you have 5 zeros, add 5 zeros. Boy, we would have been in the metric system. Correct? 6 minus 0, 8 minus 0, 0 minus 0, 0 minus 0. Okay, they're all zeros. All we have left is 86. All right, so here's what gets a little tricky. Automatically, somebody's going to see 86. Oh, 25 goes into 86 3 times, right? 3 times 25, 75. So they go straight here and they go 3. They go 3. And they say it's 183. That's wrong. Place value. What is the 8 in? What place is the 8 in? It's in the hundreds place. So now you have to go to the tens place. That's your next place value. That's where the 8 is. How many times can 25 go into 8? 0 times. Placeholders. You can't go into the 8. There's nothing that we can do. 25 into 8, 0 times in the 10th place. Now we go over, this is 86 from the ones place. So that's where the 3 is going to come from. The 3 is going to be in the ones place. And if you're not taking care of your place value, that's where the mistake's going to happen. 3 times 25, 75, we subtract. 6 minus 5 is 1, 8 minus 7 is 1. So we get plus 11 over 25, or 1,803 and 11 25ths. place value. So with that practice in, I want you to try these. $564 over 5. 564 over 55. And 51,709 over 506. If we convert this into long division, you got to know what the divisor and what the dividend is. So what's the divisor on the outside? 5. And the dividend is what we're dividing. We're dividing 564. We're dividing it by 5. So the divisor is on the outside. The dividend goes underneath 564. So when you look at this as a fraction, the dividend as a fraction, you get your numerator over denominator. That's the dividend in the numerator. Over the divisor. So when you want to convert this into long division, the dividend is in the numerator, the divisor is in the denominator. So in the hundredth place, how many times can 5 go to 5? Once. So you get 500. And now we have left as a 64. In the tens place, how many times can 5 go to 6? 1. So in the tens place, that means it's a 50. And when we subtract, we get 14. And how many times can 5 go into 14? 2. So we get 10. Subtract. We get a 4. And 4/5. And before you start raising the questions of couldn't you just? Whenever I hear the phrase couldn't you just, usually it's probably you should. Because it doesn't always work that way. Now, if you're really, really good at it, you don't have any problems with long division, then yeah, maybe you can. You could probably look at this and say, hey, that's a 50, 56. I can make 55 with the 5. But what times 5 is 55? 11. But where are you going to put the 11? Are you 11 to me? I might put it there, which is the wrong place value. Okay. You're going to get 55. You'll probably put the 55 here, and you'll subtract, and you'll still get 14. But that's in the wrong place value. If you put 11 here, then the 55 should have been here. So just be careful. You wanted 550, So you technically should be multiplying by 110 to get the 550 there. And then you can go to the one value. Place value is what screwed everything up when we're learning mathematics and taking care of it. Because it doesn't stay, it doesn't stay dividing by a single digit. Now we got to divide by 55, divided by 2 digits. The dividend is 564. The divisor on the outside is 55. I can't divide by 55. Anybody know that? Nobody. No, I'm going to stop asking the question. Does anybody know? I'm not going to get it. Yeah, I know that one. $55 cannot go into 5, so there's nothing in the hundreds place. Now you go to the tens place, you're looking at 56. How many times can 55 go to 56? Once. So in the tens place, it's just a 1 times 55. That's 550 because that's a 10. We have 14. Now you're in the ones place. So if I don't put it in the tens place, you won't realize you're now in the ones place. How many times can 55 go into 14? 0 times. So that's the remainder. 55 can't go into the 14. But if you don't realize that, you may look at it and go, hey, 55 can't go into 14, so it went in one time, so I have 1 and 14 55ths. It's not a 1 because that 1 is in the tens place, so that's actually a 10, not a 1. So you put it and start in the right place value, you'll realize, oh, I got to go to the 1. It goes in 0 times. It's a 10. What has been my emphasis today? I keep, I don't know how many times I've said it, but place value. It matters. Place value. Minus 506, the dividend is 51,709. All right. In the 10,000s, 506, we're not going to 5, so we have nothing in the 10,000. In the 1,000s, 506, it's not going to 51. So there's nothing in the thousands. In the hundreds, we have 517. From the hundreds perspective, 517. How many times can 506 go into a 517? 1. So in the hundreds place, right above the 7, we have a 1. So 1 times 506 is 506. And it terminates in the hundreds place. So it's really 50,600 because that's a 100. 9, 0, 7 minus 6, 1, 1 minus 0, 1. Go to the tens place. In the tens place, you're looking at 110. In the tens place, that's 110. And 506 going to 110. No, so it goes in 0 times. Placeholder. It doesn't go in from the tens perspective, doesn't go in at all. So now in the ones place, How many times can 506 go into 1,109? Two times. So 2 times 506 is 1,012. And then we subtract. You can't take two, well, actually, my tab, so you can go the other way around. 9 minus 2 is a 7. You can't take 1 from 0, so you borrow. That's now 0. That's now 10. 10 minus 1, 9. And then 0 and 1, 0, 97. Can you go 506 into 97? Nope. If you did it right, then it shouldn't. So we have plus a remainder of 97 over the 506. Or actually, I'm going to write it this way first. X squared minus 6x minus 16 divided by x plus 2. So this is a preview. We're going to do it again. 10 o'clock. But we set it up the exact same way. We have a dividend divided by a dividend. So we draw that little division symbol. We put the divisor on the outside, so the x plus 2 goes out here. And then we put the dividend underneath, so the x squared minus 6x minus 16 goes under here. And we start dividing. Polynomials have place value. First of all, the place value has to be in the correct order. When you write a polynomial, you want all of the terms to line up from left to right, but in decreasing degree of the variable. And we've talked about that before. So the biggest power of the variable x should be x squared, and then x to the first, and then x to the 0. It's a constant. So the degrees of the variable should be in decreasing order. That's going to help you out. We wouldn't put the 1s in front of the 10s. We don't want to put an x in front of the x squared. Order matters. Place value. Because these are our place values. This is the place value of the x squared. This is the place value of the x to the first. That's the place value of the constant. Everything adds up. Okay. Then, just like we did over here, 506 into 5? Nope. 506 into 51? Nope. 506 into the 517? Then we started right above the 7. But when we're looking at this binomial, all you care about, the only thing that matters, nothing else matters. You do know much of color, right? You heard that? No? No. 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 They don't matter. They're crap. Sorry, they're crap. Go back to the 7. Very good one. All you care about is this. The first term, that's it. That's all you do. And all you want to do is ask yourself, what times x is x squared? Just like you're factoring. What times x is x squared? X. X times x is x squared. X times x, it equals x to the 7. So it's x to the first and x to the first. X to the first does not go over x squared because it's a different power. X to the first is going to go here above the x of the first term. Place value. That also lets you know that if my quotient starts here above the x of the first, the answer is going to, I can't go any further than the constant. I'm only going to have two terms of the answer. Okay. Once you pick, like right here, when we got to this stage, 1,109, and we go, how many times can 506 go to 1,109? And we're in the ones place, and you pick 2. What did you do with the 2? What did you do with the 2 once you picked the 2? Multiply. You pick 2, you multiply by 2, and then you do the subtraction. So we pick x. Now you have to multiply by x. X times x. But there's 2 things here, so you have to distribute. X times x is x squared. X times 2 is 2x. Now, practice enough, you don't have to write it on the side. I will write it on the side until one time I'll try not to, and if somebody says, how'd you get that? Then I'll write it back on the side. I see I'm writing this x, so x times x is going to give me x squared right under the x squared term, so the place values line up. And then x times positive 2 is a positive 2x right under the x of the first term. Okay. Bear with me here for a second. What's the next step after you multiply? Subtract. All right. It was nice when they were numbers. But when we do this, this is what's going on. You're going to subtract this whole thing. Which, getting you guys, or again, the thousands of students that I've ever taught, getting them to put parentheses. Okay. Is a challenge that just doesn't seem to have to work. You're going to subtract, so you know what you're going to do? Let's just pretend that we did put parentheses. So that means if I put parentheses and then I'm going to subtract, you would distribute the negative to each one. So let's just distribute the negative to each one and subtract each one. You're going to subtract each one. Do it that way. That way you distributed the negative to each one, you're going to subtract each one. And now we got it. You know you're doing it very well if these two cancel out, because the only reason we chose x is so we can multiply times x to get this canceling out, to get a perfect, the same thing as x squared. So when I subtract, this is gone. X squared minus x squared gone. Negative 6x minus 2x. What do we get? I have negative 6x, and I'm going to take away, subtract 2x. When you subtract a positive, this just becomes minus. Negative 8x. And then minus 16.
Yeah.
So that was this place size, the x place size. So now we go over to the constant. right here. And we're looking at the first term, this x, and we want to make this first term, negative 8x. We want to know what times x, question mark, is going to give me negative 8x. What times this x is going to give me negative 8x? I need it, no, but just a negative 8. A negative 8 is what I need to multiply this x with. A negative 8 times this x will give me that. And again, place value, in this place value, I don't have x. It should just be a constant. The only place I have an x is here. If I had x squared, the only place they would be here. So this is just going to be a constant. What am I going to multiply by? I need a negative 8 times this to make that. So right here, it's going to be a negative 8. So now we distribute. That negative 8 times the divided, x plus 2. Negative 8 times x is negative 8x. Negative 8 times positive 2 is negative 16. So when we distribute, we get negative 8x minus 16. You don't, again, pointing out, you don't have to show me it, over here on the side, the multiplication. You can, if you need to do it for yourself. But when you make the choice of negative 8, just make sure you distribute. That negative 8 times that positive x is negative 8x. That negative 8 times positive 2 is that negative 16. And remember, the next step is subtraction. And when I'm going to subtract, I'm going to distribute the negative to each one. And here's what you do. Since you're going to subtract a negative, guess what's going to happen? The positive. It becomes a positive. I'm going to subtract a negative, so it's going to become a positive. But you want to show that it's minus minus, and then you just make it positive. Just like right here, minus, and then I have a minus with that positive, so I can see that you have that subtraction, so you can see it. Don't like cross that off and then now it's a negative, because you're going to lose what it was before, and you might actually think that it was a negative, and then you end up messing up the signs in your head. So keep that here as a positive, and then you'll see when you write minus minus, this negative minus a positive 2x. So a negative 6x take away a positive 2x. That's just subtraction, negative 8x. Minus a negative 8x, so that means a negative and a negative. That's now a positive. That's a 0. They cancel out. Negative 16 minus a negative 16, that becomes plus 0. That cancels out. So the answer is there's no remainder. It's just x minus 8. If you don't have a remainder, when you divide, there's a word for that. And if we had 63, so 51, and we divide by 3, the answer is just 17. 3 goes into 51 17 times. That means 3 goes into 51. What's the word? And there's no remainder. We say 3 goes into 51 blank. I'll give you the last 2 letters. L-Y. Evenly. 3 goes into 51 evenly. There's no remainder. But there's no remainder, it goes in evenly. No remainder. No remainder, goes in evenly. When something goes in evenly, it's because they have a common factor. This is 3 times 17 over 3. The 3 is reduced, I'm left with just the 17. This is x plus 2 times x minus 8 over x plus 2. Which way is quicker? Bloody factoring, yes. You are not going to make it through higher level STEM classes if you're going to refuse to factor. Does anybody? I quote if anybody. The machine Ted Lasso. Show about the football. Yeah. There's a character on there. Football is life. Factoring is math. You got to be able to factor. Find the pieces so you can reduce it. If it doesn't factor, then you do the long division. In calculus, you have to be able to do partial fractions, which means you got to be able to do long division. Sometimes there's things we can't do. Long division comes along. Helps us do the things that we can't do, change the things we can do. I was just on, I don't know if it's a Reddit or whatever, and there was a question. Do engineers really use calculus? And you get some questions on, some engineers know. But if you don't know your calculus, all it does is close future doors and job opportunities you'll never get. What calculus does, higher level math, is create new brain pathways and understand the complexities of how things work and put together. Because it's something that you've never seen before. Math that you're dealing with right now is a static system. It is a snapshot, frozen, let's do the problem. Calculus is a system, it's a dynamic system. Everything's in motion. Let's do the math as this thing is moving. It's not going to stop and let us, hey, hold still. It's going to be motion. What's the math as it moves? In elementary school, when I was a kid, we had 2 bells at recess. We had the freeze bell, and we always tried to be on the swing and jumping off the swing just as the freeze bells go. We could never freeze them here. We tried. And we had the go line up bell. Okay. Dynamic versus static. And in order to understand the calculus, you need the language of algebra. Okay. The tricks of algebra, not so much tricks, but the techniques in algebra are going to make the calculus help. We're going to help the calculus. So at 10, we're going to do one example with numbers and long division, and then we're getting right into the polynomial. We're also going to be dealing with a lot of calculator work in chapter 4. So you're going to want to make sure you have at least a scientific calculator. Graphing calculator, fine. You know which one I use when I demonstrate problems on the board, on the overhead. So at least a scientific, something that does exponents and something with a logarithm button. Okay. All right, back to 10.